So welcome to the kingdom of Testadel. You've been summoned here by the king to serve as a special auditor. You see, the kingdom is coming out of a long period of a bloody war because one of the king's vassals, Sir SideEffects, our villain in our story, bad guy, raised a large army and rose up in rebellion against the king, tried to overthrow him. Thankfully, the king had some loyal subjects, chief among them, Lord Pure Function, a good guy in our story. And they were able to beat back the evil Sir SideEffects to eventually win the war victory. So, as is often the case in the aftermath of a war, deals were made, treaties were signed, agreements were put on paper, and your job is to make sure that everybody's playing by the rules, right? So for instance, the evil Sir SideEffects was forced to agree to military sanctions. He's not allowed to raise a large army because we know what happened last time he did that, right? So small military force, defensive force is all he's allowed to do. And on the other side, the winning side, well, the king is so happy with Lord Pure Function and the help he got from him in the war that he decided to sign a trade agreement with him. And as part of that trade agreement, well, the merchants, the king's merchants, get to go to Lord Pure Function's market and benefit from some preferential rates on various goods. So you're going to be going about the realm and just making sure that everybody is abiding by the terms of their various agreements. That's going to be your job today. Now, along your journey, you might learn a few things, I hope. That's the idea, right? So we'll learn about side effects. What are side effects in computer programming? Are they bad? Are they a good thing? Should we try to avoid them? We'll see. What are pure functions? What benefits do we get from using them? And how to test functions with side effects. And that's really the crux of our session. That's the main thing we'll be focusing on, how to test functions with side effects, and why we probably want to try to avoid doing that. Maybe. We'll see. Now, fair warning, this is a talk, kind of a beginner level talk. We won't make like a huge deep dive on some of these topics. It's meant to be a gentle introduction to concepts like side effects, pure functions, dependency injection, and unit testing. This is also the first time that I give this talk. I'm still working out some of the kinks, and I welcome your feedback. So, oh yeah, where are my manners? Allow me to introduce myself. I will be your humble guide on this journey. My name is Philippe Vaillancourt. I am a programmer. I'm involved in software development. I've been for 6 years now, and I hail from the great kingdom to the north, Canada. I'm from Montreal. When I'm not on loan to the king of Testadel, I usually serve my lord and master, Taza. Taza is a custom software development company based just outside of Cleveland. And we're hiring. So if you're looking for a job, feel free to visit taza.com and see if we could be a good fit. Now, before we send you out on assignment and start your job as an auditor, there's a few concepts we need to make sure that you're somewhat familiar with. So we'll send you to basic training. Let's head to basic training tower or island. I haven't decided yet, that area of the map. And we'll talk about side effects and pure functions. What are they? So when we're talking about side effects in computer programming, it helps to talk about side effects in general, right? Because the expression or the term side effects, we use it in computer programming, but it's also a thing out in the real world, right? So let's put our computer aside for a second here and think of side effects. When we hear the term side effect, maybe on TV or when talking with friends or whatever, what comes to mind? Do we usually think of a good thing or a bad thing? Right? Well, here's a definition of side effect from the always very reliable Urban Dictionary. A negative or unwanted effect of an otherwise positive thing, The term is most commonly used in prescription drugs, marriage as a major side effect too, your mother-in-law. So aside from that last sentence there, it turns out that that definition is pretty close to the mark if you look at other dictionaries like Webster's, for instance. That's pretty much what it is. And this word cloud, which is an aggregate of different definitions I found on the net for side effect, helps us understand that there's like two main ideas tied to side effects out in the real world. One, they're usually unintended, unwanted, unexpected. Two, they're usually bad, harmful, negative. They're not usually seen as a good thing, something that you want, right? So now, with that in mind, we can wonder, well, does that apply to side effects in the world of computer programming, in computer science? Is the same true? Is it a bad thing? Are side effects a bad thing in computer programming? Well, here's a definition from Wikipedia of what side effects are in the world of computer programming. In computer science, an operation, function, or expression is said to have a side effect if it modifies some state variable value outside its local environment. That is to say, it has an observable effect besides returning a value to the invoker of the operation. It's just one big sentence, and it's way too long. So here's a shorter version. A change made by a function to the state of things outside of that function's scope. So now that definition is not 100% complete because you can have side effects outside of functions, but for the purposes of this talk and for most cases that you'll run into, it's a pretty useful definition. So a change made by a function to the state of things outside of that function scope or body, we could say in most languages. What kind of things? What kind of things are we changing that we can say that we were actually having a side effect? Well, here are some examples. Non-local variables. Now, that's a pretty simple example, right? We've got a variable out of scope. It's a string. And now our function makes side effect, simply modifies the value of that variable, assigns a new string. So that's a side effect. Arguments passed by reference. So now we're taking in an object by reference as an argument in our function, and we change the state of that object, right? We assign a new string to the foo property. That's a side effect. Input and output. So the function is calling log on the console, so printing to the terminal. That's in JavaScript. And that's an output. That's a side effect. So if you're reading from standard in, writing to standard out, if you're making a network call, if you're reaching out to the database, if you are reading inputs from the keyboard, the mouse, your microphone, a camera, those are examples of input and output, and they are side effects. So are side effects in computer programming good or bad? Because we might have, you might have heard that we should avoid side effects, that side effects are bad, and we hear all kinds of things. But are they really good or bad? Well, it depends. Ask yourself, could you write a useful program without any I/O, without any input or output? Probably not, right? So imagine a very simple program, maybe like a little calculator program, or even simpler than that. Let's just say that our program just can add two numbers together. But there's no way to input those numbers to the program. And we never get to see the result of the operation, of the addition. It just runs in a black box. We basically have to hard code the two numbers that are being added together, right? And we never get to see the result. That wouldn't be very useful, right? The CPU would run, something would happen in there when we press the enter key to run our program, but it would be useless, right? So probably not, right? I/O is super useful to our programs. So if I/O, which is a side effect, is kind of necessary to have a useful program, how can side effects be bad? Well, they're not, really. Not in computer programming. They're not inherently bad. But they can be tricky to work with. They can be hard to test sometime if we want to do that. And that's what we're going to be talking about today. You'll learn about some strategies to do that, through your journey. Pure functions now. Here's an example of a pure function. Simple add function takes in two parameters, two numbers, adds them together, returns the value. Can't get any simpler than that. How do we know that this is a pure function? Pure functions have two traits, two characteristics. One, they don't have any side effect. And we can very easily see that that's the case here, right? No side effects. We're not changing the state of anything outside of that function. But they also have to be deterministic to be pure functions. What does that mean? What is a deterministic function? Well, a function is deterministic when the return values are identical for identical arguments. So we're seeing an example of that, right? If I call the add function with 3 and 8 as the parameters, I'm going to get 11 as the result. And if I call it again, 11. Call it again, 11. Turn off my computer, boot it back up, run the program, 11. You know, it's raining outside, 11. No matter what happens, you'll always get 11 if you pass in 3 and 8. No matter what the state of the program is or the system, that's what a deterministic function is. And that is very powerful because it allows for some interesting optimization. That's beyond the scope of this session, but if you're interested a little bit about the topic, you can look up memoization or caching. Pure functions make that easier to happen. And also, generally, pure functions tend to be simpler, shorter. They do less. You know, they're more focused. So they're easier to test, easier to read, understand, deal with. Generally, your mileage may vary. All right, so we now understand what side effects are, what pure functions are. I think you're equipped to start your actual job as an auditor, and we're going to send you out into the realm. Let's first head to Lord Pure Functions Market. We'll start with an easy one for you. We're going to visit one of the king's allies. You shouldn't have any problems there. As a reminder, there's a trade agreement in place now between the king and Lord Pure Function, where our merchant, the king's merchants, can go to the market and they'll get a special rate on timber, right? The merchants there are not allowed to charge more than 50 silver coins per unit of timber to our merchants. So our job here is to just make sure that, you know, the merchants are abiding by the terms of that trade agreement. So if we ask for a quote on timber for, let's say, 100 units of timber, we should get a quote of 5,000 silver coins or less, right? If they want to give us a deal, they can do that, but it shouldn't exceed 5,000. So we first start with a visual inspection of the market as we walk in, take a look around, and things are looking good because we can quickly see that the merchants are using a unit price of 45 silver coins and in their quoting process. So that's great. You know, it seems like the merchants are abiding by the terms of the agreement. And just as you're about to leave and move on to some other assignment, you start thinking, well, wait a minute. Yeah, they're charging 45 today, but what about tomorrow? What if once I leave, they decide that they want to bring the price up and they start charging more than 50? So you get a brilliant idea. What if I could put together some sort of automated system that would periodically check for me that they're still abiding by the terms of that agreement? Well, that's a great idea. That's what we call unit testing or automated testing in the world of computers. And here's a simple example of a test that we could write to test something like that. It's in JavaScript. It's using the Jest framework. If you're not familiar with it, it's very simple. That test function that's being called there, that's part of the API, the Jest API. So we're testing here that we're getting a quote of 5,000 or less for 100 units of timber. Instantiate the market, call the quote timber function with the 100 input, and we expect the quote, that's what you would call assert in other testing frameworks, to be less than or equal to 5,000. Very simple. And we know, right, from our visual inspection that today, we'll be fine. We're going to get 4,500 as a result, and we're quite satisfied with that. And now we're happy because we know we can leave, and that test is going to keep running periodically, and we can feel confident that the price will be under, or we'll get alerted if ever they start charging more than 50 units or 50 silver coins per unit of timber. Or are we? Now we get to thinking, well, I'm always checking for 100. I'm always asking for a quote for 100 units of timber. What if some slightly dishonest merchant realizes that and decides to charge 45 silver coins for 100, but then whenever somebody asks for another quantity, up the price and start charging 75, for instance? Well, that would be problematic, wouldn't it? So my test is not that great. I can't feel that confident. So what's the solution to that? Well, we need more test cases, right? And there's an easy way to do that, to add test cases without having to rewrite the entire tests, and that is to I have such a hard time with that word. Introduce parameters to our test. And Jest allows us to do that in a very succinct way. We can have our 100 units for 5,000 silver coins that we had, but we can also add a test case for 10, and 1 or 1,000, as many as we want. And we barely change the body of our test right there. Now we can feel a bit more confident that even if we leave and the test runs periodically, even if the merchants change the rate or the means they use, like the way they use to calculate the quotes, well, we can feel more confident that we'll get alerted if ever they start charging too much and they don't abide by the terms of the trade agreement anymore. And why was it so easy, relatively easy, to write a unit test for this kind of case? Part of the reason why we could write a short, simple test is that that function, timber quote, that we're testing is a pure function. How do we know it's a pure function? Well, it doesn't have any side effects, right? It doesn't change the state of anything outside of its scope. But it's also deterministic, right? And that's why we can say that it's a pure function. If I am to call the timber quote function with 100 as the quantity that I'm passing in, I will always get 4,500 back as a return value. And those properties, the properties of a pure function, make for easier testing. So whenever we can, it's not a bad idea to try to write pure functions to encapsulate the logic in our programs. All right, good job. You've completed your first assignment as auditor. Everything looks good in the world of Lord Pure Function. You're now ready for something a little more challenging. We'd like you to head over to Sir SideEffects realm, his domain. And as we know, Sir SideEffect is, not a good guy. He's the villain of our story. He's the one that rose up in rebellion against our king. And now he's under military sanctions. He's not allowed to raise an army that is larger than 50 soldiers. That's the maximum he can have. And we've been hearing some troubling things coming from Sir SideEffects' domain, his castle, his lands, and that's why we need you to check in, right? So the way this works, because there's so much bad blood and mistrust between Sir SideEffect and the king, there was an arrangement that was made for some sort of verification to make sure that he's abiding by the terms of the peace agreement. And that is a third-party neutral scribe was selected by both parties, and that scribe took up residence inside of Sir SideEffects' castle, and the scribe is in charge every month of writing up a report, counting how many soldiers are in the barracks. And the king can send a delegate up to the castle gate, because castle gate's always closed. Sir SideEffect is paranoid. No one gets in, no one gets out. Right? So you go up to the castle gate, And you yell, all right, can I get the report now, please? And they toss over the scribe's report over the ramparts. You open it, and that's that. You can check that the number is less than or equal to 50. So a unit test for that would look something like this. Very similar to the test we wrote for the trade agreement, isn't it? We instantiate the new castle, we call the soldier count function, we get an army size back, and we assert or we expect that army size to be less than or equal to 50. Great. And that worked. That worked really well for several months. We'd get 43, 47, 44 as a result, and you would expect that fluctuation, right? Because obviously people enroll into the army, people get discharged, some people get injured, whatever, so it fluctuates. But for the past 4 months, we're getting 50 every month, 50, 50, 50, and that's suspicious. That's kind of weird. On top of that, we're starting to hear rumors that that neutral third-party scribe might not be so neutral after all. There are people saying that he was bribed by the evil Sir SideEffects. So we've got a problem. We don't trust the result that we're getting from that report that's being tossed over the castle walls, right? So what do we do in a situation like this? Well, what do you do when you're trying to find out what's happening inside the enemy's camp? And you don't, he doesn't want to give you that information, not being forthcoming. Well, usually nations will send in spies, right, to gather information about their enemies. And that is exactly what we're going to do. Oh yeah, and we're not supposed to see this, but here's the proof that there's something weird going on inside of the castle, right? So yeah, we need a spy. And spies in the real world, that's a thing, right? But spies in the world of computer programming is also a thing. There are things called spies, and they're very useful when we're trying to find out what's happening inside of a class or a function at runtime. So we need to get a spy in. How do we do that? The castle's walls or gates are always closed. We've checked, there's no back doors, there's no underground tunnels, we can't scale the walls, they're too high and there's guards. So how do we get in? Well, the only way is through the front gates. We've determined that the best way is through the front gates, but they're closed. So what we need is for someone to come out so we can sneak in. Or actually, even better, if we could disguise our spy as the scribe and get him to take his place, now we'd be in business. We'd be set. We could really easily access the barracks, we could count the soldiers, and we could get the correct information. And so that's what we set out to do. To get our scribe to come out of the castle, the king has a brilliant idea. He goes, yeah, I have a forger on payroll. He's really good. So we're going to send a letter to the scribe. I'm going to pretend to be Sir SideEffects. I'm going to say, you know what, from now on, I'd like you to live outside the castle. I think the king is getting suspicious about our little deal, right? So it'll look better if you live outside the castle because you're supposed to be a neutral third-party scribe, right? So the scribe obeys, takes up residence outside the castle. So now every day, instead of working from home, now has to, go to the castle. They let him in, they open the gates because they know him. They let him in and he gets to work. And the evening he gets out, which gives us the perfect opportunity to knock him over the head, steal his clothes, put them on our spy, and send the spy in, right? And that's exactly what we're going to do in code. As we see here, we now get the scribe to go through the main gates. That's our constructor right there. A constructor dependency injection is a very common way to inject a dependency, infiltrate a class, if you will. And that's what we're changing here. Now our scribe, it used to be newed up, right, instantiated inside the class. Now we need to provide the class with a already instantiated scribe. And that gives us an in. How are we going to get our spy to infiltrate the castle now? Well, remember we had to knock the scribe over the head and take its clothes. So we have to assume the identity of that scribe. Our spy will become scribe-like, if you will. And what do we know about that scribe? Well, if I'm coming back here, if we look at that soldier count function, right, that's where the scribe does his work. We see that he has a count soldiers function. That function takes in the barracks, which is an array of soldiers, and that function returns a number, which is supposed to be the count of soldiers, right? So we're going to make our scribe or spy look exactly like that by creating or giving it a function called count soldiers and takes in some barracks as an argument, and we get to decide what the implementation is. That's what's great about this, right? So we're actually going to count the number of soldiers in the barracks, and we're going to return that number, but we don't trust that report to actually make it over the wall without being modified, right? We don't trust that result anymore. So what we're going to do is we'll get our spy to put that number, right, the soldier count, in a little pocket that he has. And now we're going to check directly with the spy at the end of the day what the army count, the soldier count is. So we modify our test case to use our new spy scribe. We inject it into the castle. That's how our spy infiltrates the castle. We still run that soldier count function because that's where the scribe does his work. But now we assert, or we expect, that the number that the spy has on that little piece of paper in his pocket is less than or equal to 50. And lo and behold, it's 125. Oh no! Yeah. Sir SideEffect has been up to no good, as we feared. But as if that wasn't enough, we're also hearing troubling rumors that Sir SideEffect has taken to the dark arts, and he has acquired some sort of mystical, magical artifact that allows him to communicate with anyone, anywhere, at any time. Some say it's called the console. And we're a little scared about that because, I mean, Sir SideEffect, you know, when he rose up in rebellion against the king, well, he did manage to convince quite a few people to join his rebellion. So if he's now allowed or able to just start communicating like this with anyone, that's kind of dangerous. So we want to make sure of Sir SideEffect's intent, but what can we do? That console, that magical artifact is just, it's hidden away inside the castle. We don't have access to it. Well, we should by now have an idea of what kind of strategy we can use to find out what kind of messages are being sent by Sir SideEffect. Right? So our court magician, aware of the problem, reaches out to us and says, you know what? I am aware of this magical artifact called the console, and I actually can make a copy. I can replicate it. I'm going to call it the moxole, and it's going to do exactly the same thing as our console, except that we'll get to intercept those messages and see what they are. So that seems like a great idea. So the magician gets to work, and he makes a console clone or console-like object, the moxole. Here we can see a different way of making a spy. Many test frameworks will give you some utilities to do that. Jest has a very simple function to do that. It's called .fn, and it's a lot easier, or at least more concise, right, to use things like that. Instead of kind of rolling out your own mocks. But there are advantages to doing both. Anyway, so that's our spy right there. It's a kind of spy. And what do we need to do? Well, we know we need to get it in. We need to get it in the castle, and we need to convince Sir SideEffect to start using that instead of his console. Right, so again, the king has a brilliant idea. You know, I've got that forger, remember? He's really good. So we're going to send Sir SideEffect a letter, and I'm going to pretend that I'm one of his allies, because I'm pretty sure that's who he's communicating with. And I'm going to say, you know what, I'm not getting your messages anymore. There must be something wrong with your console. Here's an updated version. Why don't you use that instead? We're going to leave that in front of the castle gates. Guards will see it with the message. They'll bring it in and start using it. And that's exactly what we do, right? So now we inject our magical artifact in our constructor, and Sir SideEffects starts using that instead of just depending directly on the console. And that allows us to write a nice little test using our mock soul, injecting it inside of the castle, and we're going to assert or expect that the message that's going through that artifact doesn't contain any treasonous talk. You know, the text, "death to Testadel," should not appear in the message. But unfortunately, we know that it does, right? So as we run that test, now we know. We know for sure that Sir SideEffect is up to no good, and he's planning, again, to go to war and rise up against our king. So it looks like the peace will have been short-lived, and we need to make preparations for war. At least your work as an auditor has allowed the kingdom to prepare for this. And that's the end of our story. Some lessons we can learn, or some takeaways, I guess, from what we've learned about testing side effects. Let's go back to our pure function, right? Our pure function example from the beginning. Very simple add function. What if we wanted to test this function? Super easy, right? 2 lines. That's it. We pass in 2 and 5, and we check that it returns 7. That's great. But if we want our program to be useful, we need I/O. Right? We can't just have like functions that don't have any I/O. We need I/O at some point in our program. So we modify that function, and we call it print sum to console, because we want to see the result of that operation. So we're still doing that x plus y thing, but now we're just printing that to the terminal instead of returning it from the function. Seems reasonable, right? Now our program does something. We can actually see what it does. Great. And what if we wanted to test this? And we know how to do that now. This isn't in a class, but dependency injection works as parameters in a function as well. It doesn't need to be in a constructor. So we pass in our console, our terminal there. We start using that instead, which allows us, when we're in production, to use the actual console. But when we're testing, we can use a console spy. But you can tell, and these are very simple examples, right? But even then, you can tell that this test is more complicated than this test, right? But we're testing the same thing. We're testing that we're adding 2 and 5 together properly, and that returns 7. But because we're now dealing with a function that has side effects, we need to have a mock or a spy, and it's a little more involved. Now imagine that you had some real code from a real application. They tend to be a little more complicated than that simple example. Writing mocks or spies can get pretty tedious and involved, and you sometimes end up having to change your tests quite a bit when you're dealing with functions that have side effects like that. So it's, whenever possible, it's good to have code design that allows us to write these kinds of tests, if possible. So would there be a way to print the result of this addition to the console so that it's a useful program to the user, but have simpler tests to make sure that we're adding stuff together properly? Well, yes, right? We can change our design and come back to our simple pure function to encapsulate our business logic, right, our addition logic. But we still retain that print sum to console function. But now, instead of doing the actual work in there, all it does is print to the terminal and delegate the actual interesting work to our other function, the add function. So now we can have a unit test for the add function. And if we choose to, we could still have a test for print sum to console. We could, but for such a simple case, we can probably trust that we've typed things correctly and we're delegating correctly to the add function. That's up to you, I guess. But it's just to illustrate that when you start writing a lot of unit tests and that you have functions that have side effects and you end up having to write all these mocks, you feel the pain. And that can steer you towards better design, where your tests become simpler and easier to maintain. So some closing thoughts. Are side effects bad? Yes, no, yes, maybe, it depends. Well, the fact is that they're very useful in computer programming. So we can't, let's not confuse side effects out in the real world and side effects in computer programming, because they're necessary in computer programming for useful programs. But they can be harmful or tricky or difficult to work with, right? The same things that make side effects in the real world a bad thing can be applied to side effects in computer programming. So they're bad if they're unexpected or unintended. So if you have a function that has side effects, try to be explicit about that, maybe with a good function name, so that when future you calls that function or another coworker, he's not surprised that stuff is being done on the database or some other kind of I/O, for instance. That would be like laying a trap, right? If you had a function that's called do absolutely nothing, and it writes to the file system, and it sends a network call, and you get the idea, right? The other thing is they can be bad if they're mixed in with business logic. As much as possible, try to separate side effects from your business logic. The same way we did with our separating the printing to the console and our add function. Because if you have them together, that's like having a little bit of poison with a nice cake, right? It can be a real problem. Much harder to test and separate things. So whenever you can, try to use pure functions. That's an example of pure function, a different way of writing that add function that many people hate if they're not used to that kind of syntax, but it's just to illustrate that pure functions can often be quite small and simple and easy to reuse, to understand, and to reason about. If you do have to test a function with side effects, and you will, well then, think of dependency injection. That's one of the most powerful tools you can use to make testing those functions easier, right? Start depending on abstractions, passing in through the constructor in an interface instead of depending directly or newing up classes or objects inside of your code. If you do start dealing with mocks and spies, you'll probably want to use a third-party library to help with that, although there are benefits to writing your own. So I showed some examples of using Jest, the Jest framework in the JavaScript to do that. But if you're in the C# ecosystem, a very popular one is MOQ, mock. I've also thrown in there fluent assertions. That's not a mock library, but I like it. If you like the way Jest works with those kind of human-readable assertions, expect, that is greater than, and things like that, you'll get that from fluent assertions. If you're in the Java ecosystem, Mockito is a really popular one. Actually, it's so popular that pretty much every other language has made a port of that library. So if you want to have Mockito in JavaScript, you can have it. They have it in C# as well. They have it in a lot of different languages. So that is it for me. Thank you for listening to me talk about unit testing. I do believe we have a little bit of time for some questions. I don't know how that works. Do people just get up, raise their hand? I can't see much, so. And I think we can, do we have questions from the other theaters too as well, or? Just start talking because I can't see anything. Who won the war? Well, the first one, it was the king. Who's to say about the second one? I would say probably the king because he's prepared, right? Thanks to his spies, he knows what's happening, so he gets to prepare for the worst. Good question. I should have like some sort of follow-up on that at the end of the talk. Yeah, that'd be cool. Yeah.
What about using properties instead of arguments?
Instead of
Constructor or function arguments.
right, so like I did in the last example, in just to make sure we're talking about the same thing. Yeah, the question is what about using properties instead of constructor injection, right? Is that what you, okay. Yeah, so let's see here, right? So that would be an example of that? Is that what you?
That would be an argument still, wouldn't it? Or is that a property of a class?
Okay, you mean like properties in
the C# like class.
Oh.
On the object.
Right.
Pros and cons to that?
That's a very good question. I'm more of a JavaScript guy myself, so that's something to look into. Do you have any ideas about that?
Yes. We have properties in JavaScript, don't they? On classes?
Well, yeah, but if you use functions, which people tend to do a little bit more in JavaScript.
It does sound fair.
Yeah.
In C# it can be a good way to do it sometimes, but also it means if you forget to do it, you don't have that dependency set to anything unless you give it a default.
Right. Yeah, okay, I get what you're saying now. Yeah, I don't know. I've always thought the safest and more explicit way was to use a constructor injection for that kind of thing. So that's probably what I would recommend usually. Thank you. Thanks. Great question, Steve. All right. So I think that's it. Thank you very much.